Welcome to the world of the unknown, the unexplored, where science merges with imagination. Welcome to the world of multiverses. Picture a reality where there's not just one universe, but a colossal number of them. This isn't some science fiction fantasy, but a hypothesis that has gained traction in the scientific community. The concept of multiverses is no longer a mere figment of imagination, but a serious proposition backed by theories in quantum mechanics and the study of black holes. The idea of multiverses isn't new. It's been around for a while, lurking in the shadows of our understanding of the cosmos. But why? Why would scientists even entertain the idea of multiple universes? The answer lies in the peculiarities of quantum mechanics and the mysteries of black holes. In quantum mechanics, particles can exist in multiple states at once, only settling into a single state when observed. This concept, known as superposition, is absolutely mind-boggling. It's as if reality is undecided until we look at it. How does this tie into multiverses? Well, some propose that for every possible state of a particle, there could be a universe where that state is reality. Meanwhile, the study of black holes has also hinted at the possibility of multiverses. Some theories suggest that black holes could act as gateways to other universes. While we're far from confirming this, it's a tantalizing idea that keeps the concept of multiverses alive. But just how many multiverses could there be? According to string theory, the number is staggeringly large, potentially as many as 10 to the power of 500. That's a 1 followed by 500 zeros. It's a number so large it's almost impossible to comprehend. So the concept of a multiverse is not just a product of wild imagination, but a serious scientific proposition. It's a hypothesis that dares to challenge our understanding of reality, to push the boundaries of what we believe to be possible. But what evidence do we have? Let's dive in. Inflationary cosmology, a theory proposed in the 1980s, provides our first piece of evidence for the existence of multiverses. Now let's delve into this theory a bit more. Inflationary cosmology is a modification of the Big Bang theory. It suggests a period of extremely rapid expansion of the universe, a fraction of a second after the Big Bang. This idea was proposed to explain some puzzling aspects of the universe, like why it appears so uniform and flat. But the theory also has some far-reaching implications, one of them being the concept of multiverses. Imagine blowing up a balloon. As you inflate it, the surface expands. Now picture this happening at an unimaginably fast rate. This is akin to the inflationary phase of our universe. And just as the surface of a balloon can have tiny bubbles, so too can our universe, according to this theory. But these are not just any bubbles, these are bubbles of space-time, each potentially a separate universe with its own laws of physics. The theory suggests that during inflation, quantum fluctuations could have caused different regions of space to stop inflating at different times. These regions then become separate bubble universes within a larger multiverse. So our observable universe could just be one of these bubbles, a tiny part of a much larger multiverse. These bubble universes are not just theoretical constructs. They leave imprints like cosmic microwave background radiation, the afterglow of the Big Bang. This radiation is remarkably uniform but has tiny temperature variations. Some cosmologists suggest that these variations could be the marks left by other bubble universes bumping into ours in the early stages of the universe. Now, this is not definitive proof, but it's a tantalizing hint. The inflationary cosmology theory provides a framework within which the existence of multiverses is not just possible, but also probable. So, inflationary cosmology gives us our first scientific reason to believe in multiverses, but there's more. Quantum mechanics, the science of the very small, also hints at the existence of multiverses. This field of physics, which delves into the behaviors of particles that are smaller than atoms, introduces an intriguing concept known as the many worlds interpretation. The many worlds interpretation of quantum mechanics proposes a mind-bending idea. It suggests that with every quantum event, a particle moving from one place to another, a particle decaying, a photon of light being absorbed or emitted, a new universe is created. Imagine a single particle of light, a photon, hitting a leaf. This simple event could spur the creation of two universes. One where the photon is absorbed by the leaf, helping it to photosynthesize, and another where the photon bounces off, leaving the leaf in the shade. Each quantum event, no matter how small, could theoretically branch off into its own universe. Now let's consider the sheer volume of quantum events happening every moment. It's estimated that there are approximately 10,000 vigintillion quantum events per second. That's a 10 followed by 63 zeros. If each one of these events led to the creation of a new universe, the number of universes being born every second would be mind-boggling. It's like an eternal cosmic lottery, with new winners, or in this case, universes, being drawn every fraction of a second. And remember, this is just one interpretation of quantum mechanics. There are others, each with its own fascinating implications about the nature of reality. Quantum mechanics, then, provides another tantalizing hint at the existence of multiverses. But there's one more piece of evidence we need to discuss. Our final piece of evidence comes from one of the most complex theories in modern physics, string theory. String theory, which initially emerged as a framework to explain the behavior of hadrons, has evolved into a vast and beautiful mathematical landscape, promising answers to some of our most profound questions about the universe. String theory postulates that the fundamental constituents of reality are not point-like particles, but rather one-dimensional objects, or strings. These strings vibrate at different frequencies, and the varied vibrations give rise to the different fundamental particles we observe, such as electrons, quarks, and even the elusive graviton. Now, where does the multiverse come into play, you might ask? Well, string theory doesn't just stop at proposing a new way to look at particles, it also predicts that our universe is not the only one. In fact, it suggests that there are 10 raised to the power of 500 different possible universes, each with its own laws of physics. This enormous number, which dwarfs the number of atoms in our observable universe, arises from the many different ways these strings can vibrate, and the many possible shapes that extra dimensions can take. Each of these configurations could correspond to an entirely different universe, with different physical laws and properties. This notion of a string landscape of diverse universes is a radical departure from our traditional understanding of the cosmos. It challenges us to rethink what we mean by a law of physics, as what we consider universal laws might just be local bylaws in our corner of the multiverse. It's important to note that string theory is still a work in progress with many challenges to overcome. However, its mathematical elegance and its potential to unify gravity with quantum mechanics make it a compelling candidate for a theory of everything. So, string theory, quantum mechanics, and inflationary cosmology all suggest that multiverses could exist. But what does this mean for us? The existence of multiverses could have profound implications for our understanding of reality. Imagine this. Instead of being the center of the universe, as we once thought, or even a small part of a singular universe, we are merely inhabitants of one of countless universes. This shakes the foundations of the Copernican principle, the idea that there is no privileged observation point in the universe. If multiverses exist, every universe could be a unique observation point, each with its own laws of physics. This gives rise to a philosophical conundrum. How do we define reality when every universe might have its own rules? It's akin to having countless parallel realities. The concept of a singular objective reality might be obsolete. Furthermore, it challenges our place in the grand scheme. If there are infinite universes, do we matter at all? Or does it make us even more special, being conscious observers in our own unique universe among the infinite? The idea of multiverses also opens up the possibility of universes with different dimensions, different forms of matter, even different concepts of time. It's like an infinite playground for the imagination, a testament to the potential creativity inherent in the fabric of reality. So, while the existence of multiverses is not yet proven, the evidence is mounting, and the implications are staggering. Welcome to the world of the multiverse.